from IBM Research Africa, and his talk is about software engineering in research, lesson learned doing AI research in Africa. Mr. Sekou, he is coming from the IBM Research Lab, and this is one of the, if not the first, research lab in the African continent. And the floor is yours. Thank you very much.
All right, thank you very much. Hopefully you all can see my slides. Thumbs up in the room if you can. All right, thank you. All right, so good afternoon, good morning, and good evening to those who may be in a slightly different time zone. My name is Sekou Remy. I indeed am a research scientist based in Nairobi, and I am at one of the two locations of IBM Research Africa. There's Kenya, and then there's South Africa. Today, I'll be presenting a very small sliver of some of the work that we've been doing. Most of the work that I particularly do is in terms of AI applications in healthcare. But towards the end, my intention is to wax a little poetic in terms of describing a few of the lessons learned. And this goes beyond the standard things that we may learn in our formal software engineering education context. So just as a bit of level set, what is AI? So the goal of AI, and there are many different ways to define it, but we believe that the best and most straightforward way is systems that can simulate human intelligence and thought processes. This is not to overstate it, but we are modest around the definition of what it means to simulate a human intelligence. AI is often conflated with machine learning, but they are really not interchangeable. ML is an element of AI, and I can actually show this a little bit more on the next slide. So there's an element of learning from experience as one way to mimic human capability. We can talk about reasoning, we can talk about planning, and those are two examples of other types of AI techniques. ML is just one. And specifically for the core of this particular work, for this particular talk, I'd like to just highlight three types of machine learning: reinforcement learning, supervised learning, and unsupervised learning. Normally, people focus on just the first two, and specifically they think about AI just being deep neural networks, which is just a type of supervised learning. However, I'd like to just, so that we can all come to the same start point, when we think about machine learning, in many cases, many interesting applications of ML in the real world have overlapping applications of reinforcement learning, supervised learning, and unsupervised learning. So why do we use AI? Well, I'm sure all of us have a strong answer on why we should or should not use AI and what we should or should not use it for. However, I think that if we were to have a coherent conversation on the topic, at the end of the day, the reason we generally tend to come to the AI discourse is so that we can achieve higher quality outcomes in times that are faster than humanly possible. The idea is that AI allows us to scale superhuman performance in some principled manner. At least that's the dream, and that's the dream that we seek to have in a variety of use cases. So this main reason basically views AI as a solution to a problem, right? It's not a solution in and of itself. It's a solution which is contextually grounded in a context. It's contextually grounded in a circumstance. We can't talk about AI without actually understanding where it is going to be applied, how it is going to be applied, who is going to apply it, right? So this is key for us. But just as a word, and borrowing a figure from our colleagues at Google, when we normally think about AI, it's really just that little box in the middle, When we think about what's this nugget? What's this thing that you're building? People think about building a model. That's what their focus is. Most of the energy, most of the vigor is just focused on a very small portion of what is actually relevant in the process of deploying AI in the real world. We have to consider configuration. We have to consider how was the data collected and what's the process through which that data was made available for use. This notion of verification. I won't go through all of this, but I'd just like to make the point that AI, or the use of AI, is a lot more than just the parts that you may see in a research paper. When it comes to the application, software engineering practices, this thing that we call DevSecOps, actually applies in this space in many ways that are, I think, the implications of which are only now becoming truly felt in a global sense. There's another element of this slide which I'd like to state. This slide does not really truly capture even the business processes associated with each of these boxes. So just in the example of data collection, you may spend, let's say, 2-3 weeks, probably even a month, just trying to figure out what are the right terms and conditions under which you can use data for a particular purpose. And that is just looking at one of these other boxes before you get to the point of being able to write a line of code. There is a lot of hidden technical depth that we should consider. Moreover, just to make this point a little bit in a slightly different manner, when we focus on that box, right, we focus on the machine, as in the machine that's doing the learning. But it's a very small box, and we ignore the human element, we ignore the business processes that exist in the context, and we ignore the world in which this whole activity or action is happening, right? Each of these presents a significant challenge to the process of developing and also deploying and also then maintaining this AI, this machine learning application in the wild. All right, so to ground this, let me use an example from some recent work that our lab has been part of. So from let's say 2018 to 2019, our lab was focused on this concept of developing a platform for disease intervention planning. Notice, yes, this was a pre-COVID effort. At the time that we began this work, our focus was actually on the disease, infectious diseases, specifically with a focus on malaria. What we viewed as an exciting opportunity from a research perspective was that there was a very rich community of practice around decision-making and policy-making in this space. There was also a very robust modeling community. So more than 50 years, people have been doing work in this space of malaria modeling. But there was now this question of how could we provide a mechanism for the AI community to enter into a coherent relationship with these first two groups. Our approach, again, beyond AI just being a very small box, was to develop an ecosystem and a platform that allowed these three classes of users to work together to help answer the question, how best do I spend $1 million over the next 5 years? In the case of a disease like malaria, we're dealing with on the order of 500,000 people impacted in a significant way with this disease. We're talking about a disease that even in this time of COVID has a significant impact on lives and livelihood. Now, our question is, how do we develop or harness technologies that can support decision makers, support domain modelers by allowing the AI community to provide value? In that space, we started off with a particular use case, working with partners in Uganda. And this element of, we started with a question. That question was, what are the different ways by 2025 we can drive malaria parasite prevalence in Uganda at a national level, so all 134 districts, to a value of 5% or less. Now again, we are researchers. Specifically, our question as researchers is how can we, in a concrete use case, this particular use case, that target, those numbers, those were not defined by our team. Those were defined by the Ministry of Health Uganda's National Malaria Control Program. We were able to read this is what their goals were. Our research effort was asking the question, what is it that we can do to harness the available models and the available data to potentially support the use case? And in essence, we wanted to convince a group within the Ministry of Health to say, hey, there's this thing called AI. Yes, you know about it, but here is how it can practically be of use in your particular use case. The broader question, our broader question is, here is a particular concrete use case. What can we do to show that there is value? How can we understand using a concrete case? We're not talking about playing a game. We're not talking about improving performance by, let's say, 0.001% on a task that does not matter. We were attempting to show how we can take existing algorithms, existing solutions, and a concrete case, and show how together, by providing a platform that the policymakers, the modelers, and the AI community could come together upon. Right? So this led to a series of activities. First, we start, again, you have to crawl before you walk. This notion of having a reinforcement learning challenge or hackathon was something that we piloted through the KDD Health Day. We also worked with NeurIPS at the NeurIPS conference and the Deep Learning in Dabo. So again, remember our focus is building this platform in a manner that we can demonstrate that practitioners from a variety of backgrounds can engage with this content. Successfully, we were able to host hundreds of teams, bringing them to a domain that they had previously not engaged. So this notion of disease intervention planning or a global health use case was something that was not widely used. Typically, you have a siloed modeling community, also connected to, maybe loosely connected to, a siloed Ministry of Health. And then you have the AI practitioners off on their own doing their thing. This work, this particular effort that was, again, started pre-pandemic, asked the question, how can we bring these together on a platform? And then, as you know, COVID came and visited in the end of 2019, beginning of 2020. So for our team, this actually provided an opportunity because all of the technologies that we're talking about, how do we understand what modeling can bring to bear? How do we understand how AI can interact with models to support the answering of a question? That's not malaria specific. So we were able to demonstrate by pivoting to onboard COVID models. Now, if we're talking about onboarding a new type of model, you better have had a system that allowed, in essence, model agnostic disease onboarding. So from an engineering perspective, because we actually did spend the time at the beginning of the process to design a system that was model agnostic and treated data in a transparent manner, we could then onboard this particular use case that was evolving. So many of us have been paying attention. Most of us have become probably now a little bit frustrated with COVID. But at the beginning, we know that there were so many sources of data. There were so many people talking about, I have developed a model or I've developed a prediction. From our perspective as engineers and research scientists, ours was the role to build a platform that can allow those communities, whether it's policymakers or modelers or the AI community, to be able to enter into the same venue, the same space. So just to show a little bit of this pivot and how that pivot was actually included with other types of machine learning applications, let's take a look at what we were asking in this covered space. So previously, we wanted to know, how do we get to 5% prevalence in 134 districts in 5 years? In essence, those were the targets. In this particular case, the questions were different because the domain was different. So people were interested in understanding, do I close schools or not? How long do I need to enforce social distancing for? Do I need a border closure? Like, these were all questions that policymakers at the time were interested in, all along the backdrop of limited budgets, limited health system resources, and also a significant amount of uncertainty about how good modeling efforts actually were. Moreover, while there was a lot said about what data were available, when you actually were able to drill down, there were the quality of the information was generally not sufficient to integrate within models. So for example, if you wanted to understand what interventions were implemented to control COVID-19 globally, and where had those individual interventions been successful or not successful, this was something that was very difficult to do. But as it turned out, our cross-lab team was able to develop a method to understand these things, and again, borrowing from the tools or the systems that were available within this machine learning space. So, for example, we know we first started out by collecting information manually and labeling non-pharmaceutical interventions, known as NPIs, that were being implemented in different countries worldwide. So for example, just looking in the blue box, in March 27th, 2020, the President of the Republic of Kenya implemented, following the reporting of an additional 3 cases, meaning this was at the beginning of our journey in this COVID case, nationwide curfew on unauthorized movement from 7 p.m. to 5 a.m. So in essence, this is an example of a non-pharmaceutical intervention. We were able to classify, or to manually in the beginning, classify that NPI into a given taxonomy. And then we were able to, this is just an example for one country, Kenya, we were able to capture a time series. Now, the idea is that we would like to automate this process because manual collection does not scale very well. Yes, you can crowdsource. However, crowdsourcing by itself is a very expensive task. So eventually, we found and agreed to use Wikipedia as a source for collecting this type of information. And at that point in time, early in the pandemic, there were already more than 400 pages capturing information from a variety of geographies and regions. And yes, this is, you can view it as, oh, well, this is still crowdsourcing just in a new way. And I agree with you. But we're just using Wikipedia as one type of example of information, of source information. And from this source information, we can generate a structured data set around the use of NPIs. And we're doing this through the use of natural language processing. So if you were to look at this first text, this first block of text, this is not an example of an NPI event, right? So these sentences are all related to unemployment benefits, which has nothing to do with a non-pharmaceutical intervention as the way that we've implemented in this taxonomy. So we were able to discard that information by using an automated tool. However, if we were to look at the green sentence on April 15th, Como, this is for a particular state in the United States of America, but on April 15th, Como signed an executive order requiring all New York State residents to wear face masks and coverings in public places, etc. This is an example how we can generate structured data out of this unstructured source, all right? And from this, what we can do here is that we can also tie the data that our system or our platform has generated along with the original source of the data when available. So this process of automation, along with verification or along with the ability to link this finding to the original source, is something that was tremendous value to the process of understanding what was happening at a global level. And we're starting with Wikipedia, but we also demonstrated in other engagements that subsequently followed how we can use local newspaper coverage and the like. So from our system's perspective, it is just an unstructured source of data through which we apply a particular process and generate the output that we're interested in. So we built a pipeline to continuously connect NPIs from over 250 regions of the world. And if information is reported at a subnational level, then that information could be included within this pipeline as well. So this was early in the pandemic. But again, what I'm trying to highlight here is because we're able to figure out how to harness natural language processing, a technology that was around and we all know it, it exists as an example of probably one of the most common examples or popular examples of AI, that by itself didn't provide a resource that can help a decision maker understand what to do or what had been done in other places. That technology, that small little box, had to be deployed within a workflow, within a pipeline, within a context that will allow them to make a decision in a coherent manner. We also understood that there was a need to do validation and curation. So in essence, yes, the machines had their role and the machines can do what they need to do, but we also needed to find a way to allow human oversight in a very scalable or flexible manner. So there was another element of the system which involved curation. So there was another element called the Windtrack Curator tool. If you'd like to see more information about this work, you can do a quick search. We did publish and open source all of the elements that are involved. But the point that I'm trying to make here is research software engineering or software engineering in research. Yes, there's an element of understanding what's the science, what's the cool nugget, but there's also an element of understanding how can that cool nugget, how can that small box of ML technique within the context of data sharing agreements, within the context of how do you deploy it in a scalable manner? How do you actually get that into a workflow, right? This is all important from a research software engineering perspective. It's not just enough to build things on demand or on request. You have to understand how your users could use a particular technology and how that technology may actually be able to be integrated within other workflows. So, but I'll get to a little bit more on that in the last few slides. So again, just to as an example of how this notion of research software engineering is a little bit different from traditional software engineering practices. It's not enough just to say, okay, well, we've built the tool, now it's there. Maybe somebody can take that source code, maybe somebody can go make a product out of it. While we do have an interest in that at some level, our primary focus is on, in essence, understanding the science, understanding how this science fits within a context. And then based on understanding the science in a particular context, making sure that we can understand what's the right infrastructure, what's the right tool, what's the right platform. So here's a sorry, I don't want to use the word variant. Here's a question. After going through this process, we started in the malaria space, then we made a pivot to include information from COVID-19. After that initial work in COVID-19, one of the questions that a partner came up with is, how do we understand the relationship between interventions and outcomes? Right? This is a very common, a very rational element. But it's one thing to say that you have a question. Now, how do we turn that question into a platform or into an infrastructure? that can support not just one particular user in one particular use case, but more broadly help decision makers of a particular type. Again, we are framing a particular use case, but help decision makers of a particular type answer a question like this. So in this particular case, this is presenting some early research work as well. We were able to ingest information which came from multiple sources. And here we're talking about maybe mobility data that's presented in a structured format with the appropriate metadata. Maybe we have information that we were able to access about non-pharmaceutical interventions at a global scale. And this could have been acquired from a source like the Johns Hopkins or maybe the Oxford School of Government. And we also can get information about case data also available. Now, the question is, can we develop a model relating to public behavior? Because it's not just enough to know what NPIs were implemented, but also how did people respond when that particular NPI was in place? And then link that to understanding the disease transmission rate. All right. I'm showing this particular, or I'm talking about this just to, again, highlight this element. We started off, we had a model that had a purpose. There were users that said, here's a question that I wanted. And now the question has changed. So in this particular case, let me actually, sorry. Hopefully you can see my mouse. In this particular case, we're trying to understand how is this transmission rate? This is largely the focus of the question. How is this transmission rate impacted by all of those other latent elements that exist in the environment? For example, if you did impose a lockdown on a particular date, how quickly did that lockdown have an impact on the transmission rate? So this is an example of what each compartment may look like. Again, you don't have to worry too much about modeling details. But the point here is that if you were to change the transmission rate in a structured manner, you can control how these curves progress over time. All right. So we have this concept of flattening the curve. We've heard it over and over again and again. In essence, what that is referring to is making a change to the transmission rate in a manner that the number of people who go from susceptible to exposed and ultimately to infectious is controlled. All right. So these interventions that we're talking about have the ability to directly target that transmission rate beta. So these users want to understand what particular NPIs actually reduce beta. Is it school closing? Is it school closing for all students? Is it school closing for students of a certain age in a particular location? How much social distancing is needed, etc. The point is, you'd like to understand, using a data-driven approach, how do NPIs and behavior impact the transmission rate? If we were to develop an answer for that question for one location, I guarantee that there are several other locations that would also be interested in understanding that construct. So as a team, when we're developing or when we're starting this process, we're engaging with sponsor users and just allowing the process, and we're talking about all of the normal techniques that you would still apply in a traditional software engineering universe. But now we're linking that question to linking those approaches or practices to a question that can actually be of benefit globally, right? So I might not be able to quantify how much social distancing is enough. However, working with partners in Uganda, DRC, Senegal, and Nigeria, we're trying to understand in this process and how we can make this process repeatable in a structured manner, and also then understand ways that AI can be used not just for the next variant, but even those future pandemics. So again, this is a journey for us, but remember again, I'm asking these questions from a research software engineering perspective. There's a lot that we can learn. So in terms of the final thoughts I wanted to touch on, Yes, we want things to be, in terms of the work that we do, to be repeatable, scalable, reliable. We'd like it to be able to run on heterogeneous infrastructure. We'd like to be able to have things that are composed into downstream tasks or workflows. We'd like auditability, transparency. Yes, yes, we want all those things as well. We are still building code in a research context. However, here are 7 things that we normally don't hear in a venue, in these kind of conversations, that I think are worth mentioning, are worth highlighting. Collaboration is essential, and so are understanding the KPIs for your collaborators. And this applies whether that collaborator is a startup or a university, or maybe even a competitor. So there are times when competitors, I think the term is co-opetition, right? So there's an element when you're building infrastructure, or maybe you're building ecosystems, and you have to understand what those KPIs are that would drive collaboration and enable a future competition. There's an element of everything takes longer in research than needed. That's a truism that I think many in the room might agree, even if you're not coming from a corporate research lab, maybe in academia. But the other element that I'd like to highlight, this third point, listen to the people that you're trying to serve. You better have your sponsor users, and you better do more than just give their words lip service. And I follow that with, let them know that you're listening as well. All right, so keeping current and identifying what you're bringing to the table is always essential. And I couple that with plant seeds. If you are an engineering lead on your team, invest in yourself and your team, because in essence, I know that there's a lot of undercurrent in the region at present about, okay, well, there's so many tech companies that are coming in, they're going to steal my talent. We can't fight to that. Whether it's another country stealing, hiring away or poaching, we can't worry about those things. Invest in the talent that you have the ability to influence, right? And then let everything else sort itself out. And then the final thing I'd like to say is measure twice, cut once, because especially when we look at our region, there's an element of, if you don't get things right the first time, you may never get another chance. Either you may not get another chance, or there may never be another chance for anybody else. So we have to be very cautious about how we go through this process of developing code that other people are using. Whether it's healthcare or whether it's financial services, we need to take this opportunity that we have at this singular moment, take it very seriously, and run with it. And with that, I think I will pause and leave some time for questions. All right, so I think I see a question on the screen. All right, so the question was asked was, at the moment, specifically in Uganda, COVID cases have been increasing lately. Did your modeling explore and probably recommend to relevant authorities some of the patterns the disease could take after 3 years? So the short answer to the question, and that's a really good question, Dinesh, we are part of a research team that is currently looking at this right now. The team is led by a secretariat, which is based in Uganda at Makerere University School of Public Health, but there are participants on the secretariat from, as I mentioned before, DRC, DRC, Senegal, Nigeria. The country I did not include was Ghana, who is now part of this process. And in their existence, because again, our role as a research engineering group is to support their science. So they are engaging with their ministries of health, not us as IBM Research. So hopefully that answers the question. Another more philosophical point, our role is to support the modeling infrastructure, support the modeling community. One of the elements when you look at that modeling community is, and I can give the example of what happened in Kenya, there was significant discourse and debate about whose model was good, whose model was not. Our role is not to have a voice in that. Our role is to provide the infrastructure to permit that modeling discussion to happen in a coherent manner. So for example, some modeling groups may have had access to data that others did not. And that might have been a reason why some of their models may not have been able to more effectively understand what might happen 2 or 3 months in advance. But our role is to support in this process of bringing all of the answers together so that in a more coherent manner, we can actually get to the question of what is likely to happen. And I would also do the obligatory disclaimer, all models are wrong, some are useful. So in this particular case, our goal is to also encourage our users to actually say, don't view it as a one is right, the other is wrong. Let's understand what is being inferred from the use of models broadly. Are there any other questions? I think your mic is muted.
Okay. حد يفتح بس المايك. Muted. Yeah, it's muted, I guess. Yeah. شوف تحت.
Okay, I can hear now.
Okay, great. Thank you very much for your presentation, and I think there are some other questions online on the platform. So I would appreciate if you can take the time, maybe answer them even offline, we can show some of the questions from the audience here in Cairo and also online. So maybe for the benefit of time, I think we will stop here. And I hope you can answer some of these questions online on the platform so everybody can see the answers. Again, I would like to thank you very much for the exciting presentation and for your time. Thank you.
Thank you very much.
Thank you.